I'm going to go over a few terms here, and I'm going to apologize in advance on behalf of science and anthropology. I didn't come up with these terms, but I'm nonetheless sorry that I have to subject you to them. Okay, so we have something we've seen in our readings. Hopefully, you've gone over this material. We have a hominoid. A hominoid refers to a family of primates that include humans and their fossil ancestors and some of the great apes. Give you an example here. Chimpanzee is a hominoid, as is a human. And I'll introduce you to one of our kind of ancestral species that's not directly related to us, Australopithecus robustus. It's a hominoid. It's in that family of primates. And if you think of a tree branching off, it's going to be on one of those branches that do not directly lead to our own species. Okay? Hopefully that makes sense. One of the words that we can use interchangeably, we're going to drop the O, shift over the I and the D, and we get a hominid. A hominid refers to orangutans, gorillas, chimpanzees, humans, plus those fossil relatives that we just talked about. For example, Australopithecus robustus. So we can use these words interchangeably. Now here comes the confusing part. Like I said, this is a little bit of like a riddle. We're going to drop the D and we're going to add an N and we get a hominin. I'm going to read to you. All hominins are hominids, but very few hominids are hominins. Like I said, that's why I apologize to you in advance. Let's look at that again. All hominins are hominids, but very few hominids are hominins. What this is getting at is while our evolution can be viewed as like a large tree, we had talked about that metaphor with a main branch and other branches that move off from that main branch and then further branches. Hominids fit somewhere on that tree, but they're not directly leading to us. So, for example, Australopithecus robustus, it's a hominoid, it's a hominid, it's not a hominin because it's not in our direct evolutionary path. It's kind of like a second cousin or a third cousin, so to speak. So, if we look at another Australopithecine, that's closer to us, for example, Australopithecus anamensis or Australopithecus afarensis, those two would be defined as hominins because they're going to be in one of those steps that eventually leads to us. Okay? Hopefully that makes sense. So, as we look into the past or the study of the past here, I'd like to distinguish between a couple of different disciplines. So anthropology only goes so far back. If you look on the right side of the screen, we're going back to the Miocene. We've talked about that already, but that doesn't mean that other researchers aren't interested in life prior to the Miocene. So we do find a number of specializations as we inquire into prehistory. So for example, we have paleontology. Paleontology is simply the study of old beings. Paleo, old, ontology, beings. And they're interested in animal and plant fossils. In contrast to paleontology, paleoanthropology, or the study of old humankind, we're interested in fossil hominins, fossil hominids, and associated artifacts. Human evolution, and while we might think that dinosaurs really didn't play a role in our evolution, they did play a pretty important role, or at least their extinction did. So dinosaurs became extinct around 65 million years ago, and we refer to this as the fifth mass extinction. And it was important for human evolution because it created a niche that allowed our species to become successful, unfortunately for the dinosaurs at their expense. What we know about the extinction of the dinosaurs comes to us through paleontology and paleoenvironmentology, so the study of old environments. And for some time, people had suspected that dinosaurs, their fate was caused by a giant asteroid that hit the Earth. and they had looked for an asteroid that was the appropriate size, the appropriate time for quite some time, and they weren't able to locate it. In the 1980s, Alvarez, he did discover such a crater in the Yucatan Peninsula in Mexico. When this asteroid collided with the Earth, it altered the atmosphere, the environment of the Earth so drastically that it led to a mass extinction event. This event we refer to as the KT extinction event, or the Cretaceous Tertiary extinction event. Here are some of the key points. 65 million years ago, this asteroid impacts the Earth and does so around the Yucatan Peninsula. Some of it's in the ocean, and some of the collision was on land as well. Researchers point out that if this was entirely in the sea, if it was in the Gulf of Mexico, it wouldn't have had the impact that it did, and that perhaps may have not eradicated dinosaurs entirely, which would have perhaps put us on a very different trajectory. With that impact, a lot of iridium and dust moved into the atmosphere. It blocked out the sun, and it created what we refer to as an extreme greenhouse effect. This causes drastic changes in temperature and reduces resources. And you can imagine dinosaurs, very large, many of them very large animals, they're cold-blooded. They can't adapt to this fast enough. That depletion of resources creates a type of a crisis. If we wanted to refer back to Malthus, we could say, hey, this is a Malthusian type of crisis. The resources just aren't there for the population. In the end, 75% of living species at that time become extinct, and the dinosaurs are one of them. Now, in that extinction event, because mammals that were emerging at that time were quite small, they were warm-blooded, they were covered in fur, they didn't require a lot of resources, they started to become abundant. So we get the success of small, warm-blooded mammals. And these mammals, some of them take to the trees and eventually evolve into the primates. Now, how do we know this happened? How are we able to successfully date the extinction of the dinosaurs? So that KT extinction event, we're also interested in a particular layer in the Earth's strata that has a very high amount of iridium in it. It's referred to as the KT boundary. Now, this KT boundary, it has blanketed the Earth. It's found absolutely everywhere. And if you're looking for dinosaur fossils, you're not going to look above the KT boundary. You're going to look below the KT boundary. And like I said, the KT boundary is significant because of the sheer amount of iridium that's found in it. And iridium doesn't occur on Earth naturally in large sources. It was deposited by an asteroid. So dinosaurs found below, when we date that KT boundary, we discover that it's 65 million years of age. That allows us to precisely date the extinction of the dinosaurs in this KT mass extinction event. In the same way that we had discussed epochs when we were covering the primates, we're going to need to do a few more epochs here with human evolution, and we also need to discuss a few different periods. So let's start with the Pliocene. The Pliocene is an epoch from 5 million to approximately 2.5 million years ago. And this saw the emergence of a genus that we refer to as the Australopithecines. Now there's a number of Australopithecines that we will discuss a little bit later on, but let's just remember in this Pliocene epoch, that's where we see the dominant species is the Australopithecine. The Pleistocene saw the emergence of the Homo genus. So at around 2.5 million years ago to roughly 20,000 years ago, that's the epoch that we refer to as the Pleistocene. The Holocene, around 20,000 years ago, up until more recent times, that sees the birth of agriculture. Now, in addition to these three epochs that we need to be able to refer to in this particular module, we also have a number of periods. And our periods refer to different types of stone tool technologies. So as soon as stones emerge as a type of modified object, as a type of tool, we have now entered what we refer to as the Paleolithic Stone Age. So Paleolithic, this is the Old Stone Age. It begins at about 2.5 million years ago, and it starts off quite simply with the work of Homo habilis. The Paleolithic eventually leads to the Mesolithic, which means Middle Stone Age. And the Mesolithic, it represents a different type of stone tool technology where people began to create, for example, a type of axe, an adze, and some of the technologies were based upon grinding grains that were starting to become abundant. Eventually, we see the Neolithic, and the Neolithic refers to the New Stone Age, and these are tools that are particularly designed for farming or agriculture. So, like I said, take a look at these. We need to remember three epochs: the Pliocene, the Pleistocene, the Holocene, and then the tool traditions, the Paleolithic, the Mesolithic, and the Neolithic. I will be referring back to these. Another important concept to deal with before we start to talk about our own evolution is where we evolved. And, historically, there's been a lot of debate whether or not humans evolved in Europe. That was originally where people had anticipated the emergence of humankind. However, anthropology has shown different. We know that Africa is the cradle of humankind. So if we look at this map of Africa, we see a distribution of a number of different sites. We'll have a video a little bit later on that'll talk about this. And we can see that the earliest anthropological discoveries, they were found in Sterkfontein down in South Africa. So that's represented by a light green square. And there's a park there referred to as the cradle of humankind. So that's where we found the majority of hominid fossils. A little bit later on, as we started to move into the 1970s, the 1980s, we started to find more fossils along that Rift Valley. So we see a cluster of archaeological and paleoanthropological sites from Arawash, Hadar, and around Lake Turkana and Kubifora. These are all the significant discoveries. The other important thing to remember about our evolution, not only did we evolve in Africa and later migrate out, but we tend to migrate on that eastern side of Africa. And if we look at the type of environment that's there in contrast to the rest of Africa, we don't see the dense types of forest that is characteristic of African jungles. In these areas, we tend to get more of a savanna, open grasslands with fewer trees.